Okay, so here's our lesson on slope, intercept, form, and graphing. And I'll tell you, today I'm going to be one of those teachers that has shown you the hard way how to do something, and today I'm going to show you really the simpler way to do some of the things that we've done so far. So slope, intercept, form, you've learned before, is this formula y equals mx plus b. And as you may or may not remember, m stands for my slope. You may also notice that it's the number with the x, so instead of slope, you could also think of it as our rate. And because we're talking about slope and graphing, we need to think about it as rise over run. And then b, that's the number that's by itself. So if you think about when we did arithmetic sequences, this is my starting value. And remember, mathematicians start at 0, or officially this is my y-intercept. And that should make sense when we think about starting at 0, because y-intercepts are written in the form 0, comma y. So that's why we think about it as starting at 0. So before we do a few examples with graphing, I just want to remind you and show you some things about how to interpret slope. So remember, we just said that slope, when we talk about graphs, can be talked about as rise over run. And in general, that means that we need a fraction. So anytime we have slope, we want to make it a fraction. So for this first example, we want to make this 5 over 1. And there are two different ways to interpret that. Rise 5, so if I write this down, this is rise over run. That means I could go up 5 and write 1, because both of those are positive numbers. So that would give me this direction, up 5 and write 1. Or an alternative to that could be to go down 5 and backwards 1. And the reason that also works is because that gives me, that's like thinking about negative 5 over negative 1, and a negative divided by negative is positive in the end. So know that anytime you do slope, you are going to end up going in both directions, so you need to think about how to interpret it both ways. Now, if we look at an example about fractions, we talked about this earlier this year, I do believe. This negative sign you have to put somewhere, and since there's only one, you cannot put it in both places. So we could treat this as negative 2 over 3, which would mean to go down 2 and right 3, because that's a positive 3. So if I draw that, that's down 2 and right 3. Or my alternative would be to make this 2 over negative 3, which would mean I need to go up 2 and left 3. And when I do that, up 2 and left 3, notice that that's going to end up giving me opposite directions, so that I will end up getting a straight line in the end. So let's look at a few of these in context. Anytime we go to graph, of course, we always want to start with the starting point. And remember, the starting point is this value that is by itself. The other one is going to be a rate. So for example A here, I'm going to start at negative 8. And then I want to make my slope into a fraction, or my rate into a fraction. So right now I've got this 2, and to make it a fraction, I'm going to do 2 over 1, which means I want to go up 2 and then forward 1. Up 2, forward 1. Now we can continue that pattern all the way through the graph. Notice that that pattern started at my starting point, not in the middle of the graph. And then we also need to make that pattern go backwards. So the other alternative would be to go down 2 and to the left 1. Because we want this to go all the way through our graph. And because they don't give us a domain, they're asking us to graph something continuous. So we draw a line and add arrows. All right, example B, very similar. We're going to start at positive 1 on the y-axis. Right, remember this is my y-intercept, so we got to start the y-axis. And then we're going to treat my slope. The first time, I always put the negative on the top, negative 2 over 3. So I'm going to go down 2 and forward 3, down 2, forward 3. And I know it kind of seems tedious to go all the way through the graph, but it's a good practice for some things that are going to come up in a few weeks. And then the other option is to go up 2 and backwards 3. Notice that that continues my pattern just in a backwards motion so that my line stays straight. Up 2, backwards 3. And then again, we're going to connect our line and make this a continuous graph. So you need to have these examples in your notes for tomorrow. All right, 2 more quick examples. Notice that C here is missing my starting point. Well, it's still really out there, and think if you don't have a starting point, that means you just need to start at 0. So I'm going to start here at 0, 0, the origin, and then again, make that a whole number, so up to over 1. And I'll be lazy since you understand what we're doing, and then we can go down to backwards 1. And we've got ourselves a continuous line. D, start at -10. Make this a whole number. Now you may notice the issue here, and I gave us this one for a reason. There's not enough room to go down 5. Right? Like I don't have any room to go down anywhere here except for maybe 1. So instead of going down 5 over 1, I'm going to rewrite this slope to make it 5 over -1, which means now I can go up 5, 3, 4, 5, and backwards or to the left 1. And then if I do that again, right, we can continue that pattern to get the points for my graph. So if you don't have room, you may need to change where the slope is or where the sign is so that you can continue the pattern in a backwards motion. All right, now not all lines are written in slope-intercept form or can even be graphed with slope-intercept form. So we're going to do 2 examples of vertical and horizontal lines in your notes today. So stick with me for a minute. Think about y equals 3. That means if we had a table of x and y values, that all of the y values would be 3. All right, that means that if you look for the change, there's no change, so your rise or your change in y is going to be 0 on the top. Well, no matter what the x value is, that means you have a 0 slope, if you remember that from this past week. So I want a line that hits y at 3, so that's the y-axis at 3, but it has a 0 slope. All right, so that line is going to be completely horizontal. In comparison, if I have an equation that says x equals -2, that means all of my x values are the same, and my y values will be maybe a range of things, but my x's are not changing anymore. So that this time when I do change in y over change in x, the bottom is going to be 0, which should make you think undefined. So that means I need an equation that hits at the x-axis this time at -2, but I now have an undefined slope. All right, so that's going to go straight up and down. That's what my undefined slope looks like. So in general, any equation that is y equals is going to be a horizontal line, and any equation that's x equals is going to be a vertical line. And our last examples for today, we're going to come back to standard form. I just want to show you how when it's easier and another option when you're in standard form. So this example, remember, is a good example for intercepts because both of my values are going to divide into 2. So because of that, I'm just going to find intercepts on this example. And if I cover up, so I'll just scribble out, if I cover up my y, that gives me 2x equals -20. So that means x is going to be -10, or I could write my ordered pair -10, 0, and I'll go ahead and plot that. And then I could also cover up my x, or plug in 0, and based on the equation I have left, now that means y is going to equal 4, or 0, 4. And then I can go ahead and plot that point as well, 0, 4. And now I've got myself my linear equation. Unfortunately, on B, remember this one isn't good because the 2 is not going to divide into the 15. So this is an example of when we want to get y by itself. So I'm going to subtract 2x first, and that's going to give me negative 5y equals negative 2x minus 15. Now, because I'm doing slope-intercept, I'm putting the x part first. It's not going to mess you up if you don't, though. And then we're going to divide by negative 5, everything. And this is where last week we just put everything over negative 5. I'm actually going to do 2 separate division problems on this other side. So that's going to give me y equals, notice here I have negative divided by negative, which is positive, but 2 doesn't divide by 5, so I'm just going to leave that as 2/5 x. And then negative 15 divided by negative 5 is positive 3. And because that's positive, I'm going to write plus 3. So notice that that sign changed. And now that's a lot easier to graph instead of even having to make a table for. So we're just going to start at 3. And my slope says to go up 2, rise 2, and run 5. Or I can go down 2 and run to the left 5. And that's going to give me my equation. Or my graph, rather. All right, so what you need to do is note which examples you have questions on and you really need a better explanation for your class, for our class tomorrow.